All right, I think we are ready to get started. Thank you all for joining today. I really appreciate you sharing your lunchtime with us and taking the time to learn a little bit more about technology as part of our Tomorrow Technology Today series. I'm really excited about the talk we've got coming up. As the season of change and growth unfolds, we're excited to have somebody who embodies these qualities in the tech world. And I'm really, really honored to introduce Sanat. Sanat brings over 20 years of experience in technology and IT solutions, including his most recent role as a principal consultant here at Improving. With a master's in computer applications and an MBA, he excels in IT strategic alignment, business process improvement, and enterprise application design. His expertise also spans into retail merchandising, program management, and product management. Today, Sanat will guide us through engineering scalable AI platforms, strategy for sustain and reuse. Just as fall inspires us to prepare for the future, this session will help equip you with strategies for building, adapting, and sustaining your own AI systems. Please join me in giving a warm welcome to Sanat. Sanat, the floor is now yours.
Thank you, Emily. Welcome, everyone. In today's presentation, we will delve into the essential elements needed to build AI platforms that scale effectively within organizations. By understanding these components, we'll explore how to ensure sustainability, facilitate collaboration, and reuse critical elements across projects. We'll cover the fundamental structure of AI platform architecture, the essential roles of MLOps, the importance of robust data pipelines, and the strategies to monitor and govern AI workflows. Each of these areas contributes significantly to developing and maintaining scalable AI solutions, especially in larger enterprises. As we go through each component, we'll connect how these individual elements not only support scalability, but also drive efficiency and reduce operational overhead. This holistic approach to platform design provides the flexibility needed to meet both current and future demands of AI deployment. Finally, I'll share some key takeaways that encapsulates the best practices for constructing scalable AI platform, emphasizing both immediate and long-term benefit to organizational strategy. So before we delve deep into it, let's see why this is important. In a typical AI development lifecycle, there are many repetitive tasks from data cleaning, pre-processing, to model training and deployment. Creating reusable components and frameworks can significantly accelerate the time to market for these new AI solutions. Having modular and reusable pieces, teams can avoid reinventing the wheel, focus on innovative aspects, and speed of deployment of new features. By enabling reusable components, we promote efficiency, reduce redundancy, and ensure consistent quality across different AI solutions. With the volume of data growing exponentially, it is critical to have a platform that is capable of handling high volume and high velocity data. Scalability ensures that the platform can handle increased workloads without compromising on performance or reliability. In today's AI-driven landscape, business rely on scalable AI platforms to deploy models at speed and manage complex machine learning operations. By designing systems that scale effectively, organizations can optimize their expenditures, which impacts the cost effectiveness of the platform. Moreover, Building for sustainability allows organizations to maximize longevity and the usability of their AI assets. An AI platform built with sustainability in mind ensures models and processes are future-proof, adaptable to changing needs, and resilient. This approach reduces costly re-engineering efforts and allows teams to focus on innovation rather than maintenance. Scalable systems come with robust monitoring, logging, and version control capabilities that help with the usage of performance of AI models, ensuring compliance with industry standards and ethical guidelines. So before we start on an AI platform construction journey, what are the key elements that it should require? The very first thing is a vision that aligns with both technical requirements and business goals, and understanding of the AI ML challenges that are occurring across various verticals of the organization. And also, we need to understand the scale of the platform. A successful AI platform requires modularity so that as we iterate on solutions, we can have seamless integration of new tools and technologies as they emerge. AI projects can be complex, requiring time-consuming stages such as data collection, pre-processing, and model training, validation, and deployment. By laying out a clear roadmap for platform construction, organization can avoid common pitfalls like scalability limitations, inconsistent data processes, or costly manual interventions. This roadmap sets the stage for an effective AI ecosystem capable of delivering high-value insights and automation at scale. Some of the key considerations in platform construction includes defining data management systems, model lifecycle process, and deployment mechanisms. These elements must work in harmony, supporting the flow of data from raw collection to model output in production environments. A well-thought-out platform reduces friction and promotes rapid experimentation and enhances reliability. The construction of an AI platform also involves aligning with organizational practices for security, compliance, and governance. This is especially crucial as AI applications are increasingly subject to regular scrutiny. Security protocols must be in place to protect sensitive data, while compliance ensures adherence to industry standards and legal requirements. So let's look at some of the core components of an AI platform. The core architecture of an AI platform involves several key systems, each of them supporting different stages of AI pipeline. Data management systems form the foundation, enabling data versioning, curation, and exploration. These systems provide the tools necessary to ingest, process, and manage data for effective model training and testing. Model management systems are essential for tracking, versioning, and storing models, ensuring that they are accessible, reproducible, and performant over time. Metadata storage and performance observations are critical components as they enable continuous monitoring and improvement of models. Training and testing tools further support the development cycle, helping to evaluate model accuracy and efficiency before deployment. Deployment systems streamline the transition from development to production. They cover application deployment, model deployment, and pipeline deployment, ensuring that each component is correctly integrated and tested for live environments. These systems also incorporate CI/CD pipelines, enhancing automation, consistency across deployments. Finally, MLOps systems encompass CI/CD as well as continuous training, image registries, and deployment scripts, which together drives the automation and scalability. MLOps enables streamlined model deployment, reducing manual intervention, increasing the overall agility of AI platform. So let's dive into each of these components. Data management systems can be divided into 4 categories. Data lakes or data warehouse, which refers to the centralized storage for both raw and processed data, allowing for ease of access, scalability, and compliance. Data ingestion pipelines automate the data collection from various sources, ensuring high frequency, real-time, or batch data collection. Data governance provides tools for cataloging, lineage tracking, versioning, and manage data quality to ensure consistency and compliance. Collaboration tools provide shared environments for notebooks, datasets, and models that help data scientists, ML engineers, and business stakeholders to collaborate effectively. Data management systems are the backbone of any AI platform, handling everything from data ingestion to exploration. Proper data curation ensures that high quality, relevant data is fed into the model pipeline. Similarly, labeling tools are also crucial, as labeled data is often necessary for supervised machine learning tasks. These tools help streamline the annotation process, ensuring data consistency and accuracy, which are critical for model performance. Data exploration tools like Jupyter Notebook, Pandas profiling, or BI tools provides insights into data characteristics, helping data scientists and engineers understand data distributions, trends, and anomalies. Effective data management systems create a single source of truth, enabling seamless collaboration across teams. These systems reduce duplication, enforce data governance, and supports compliance requirements, setting a strong foundation for scaling AI within an organization. For example, take an autonomous vehicle company that rolls on complex AI models for real-time navigation and object detection. To achieve this, it must have robust data management for real-time data collection, model management to track model performance, and deployment systems that can push updates instantly. By organizing these core components effectively, the company ensures its AI platform can support high stakes, rapid decision environments like navigating busy intersections where reliability and speed are crucial. Let's go over to model management systems. It can be also divided into 4 parts. Experiment tracking refers to tools like MLflow, weights and biases, TensorBoard, or internal solutions that can be used to track model parameters, metrics, versions, and facilitating comparison and reproducibility. Automated model training refers to pipeline tools like Kubeflow or Airflow that can help orchestrate model training workflows and enable hyperparameter tuning and optimization at scale. Model storage registry are used to store models, track their versions, dependencies, and metadata, which streamlines the process of staging, approving, and promoting model to production. And model serving infrastructures provides a scalable, low latency serving solutions like TensorFlow serving or cloud native services that allows real-time and batch predictions. Model management systems play a central role in tracking versions, performance, and metadata. A model repository allows centralized storage, ensuring that model can be accessed and reused across different projects. Metadata storage facilitates the organization of model details, such as training hyperparameters and performance metrics, which are critical for model analysis and improvement. Performance tracking is also an essential feature as it enables monitoring and model accuracy, latency, and other metrics over time. Observability tools within the model management system help identify performance degradation, enabling timely retraining of the model or model replacement when necessary. Training and testing tooling further enhance these systems, allowing for rigorous model evaluation and validation. These systems create a structured, reliable model lifecycle, supporting everything from initial deployment to ongoing maintenance. By maintaining a detailed repository of models and associated metadata, organizations can ensure compliance, streamline audits, and promote reproducibility across AI projects. For example, imagine a media streaming company that recommends movies and series based on a user's history. To manage dozens of recommendations model, and the company uses model management systems that track versioning, metadata, and performance. These systems allows the company to monitor which model performs best and roll back if some model is not performing up to the mark, so that it can keep up with the changing content trends. Model management provides the company with a clear life cycle for each model, ensuring accurate and up-to-date recommendations. The next important part is MLOps and automation. It has different parts. To begin with, it deals with containerization and microservices. Containers allows models to be packaged with dependencies and easily deployed in different environments. Automated pipeline implements CI/CD process specifically for machine learning, facilitating the frequent release and testing of models throughout integration with data validation, model validation, and deployment workflows. Infrastructure as code uses tools like Terraform or CloudFormation to automate and manage infrastructure for scalability and repeatability. MLOps also provides distributed computing frameworks like Spark to process and train on large-scale datasets. Provides scalable infrastructures with the ability to dynamically allocate resources based on workload demands, leveraging cloud or Kubernetes clusters. It also provides tools to monitor usage and optimize costs to compute storage and network resources. MLOps or machine learning operations automate many of the repetitive tasks in model deployment, reducing time to market. It includes continuous improvement, continuous deployment, and continuous retraining pipelines. Automated pipelines can manage the flow of data through each stage, allowing for faster and error-free deployments. These pipelines are essential for maintaining model quality, consistency across different environments, for testing to production. Implementing MLOps also improves collaboration between data scientists and operations teams. It creates a shared automated workflow which helps collaboration of data scientists and operation teams. MLOps minimizes bottlenecks and accelerates the AI development lifecycle. It ensures that models remain up to date and adaptable to changes in data or business needs, providing a solid framework for scalable AI deployments. For example, take a financial institution that uses machine learning for real-time stock trading strategies. With MLOps, the institution automates model training, testing, and deployment, enabling it to rapidly adjust trading models based on the latest market data. MLOps automation reduces the time it takes to move a model from development to production, allowing the institution to remain competitive and respond to market shifts instantly, improving overall trading performances. One of the important aspects of a scalable AI platform also includes monitoring and observability. It can be divided into three parts: performance monitoring, which tracks the model accuracy, drift, latency, and other performance metrics in production to detect any issues that happen early. Logging and error handling provides a comprehensive logging of data, predictions, and model errors to allow thorough troubleshooting and quality assurance. Dashboards provide a visual insight into data, model performance, and system health, enabling non-technical stakeholders to understand key metrics. Monitoring and observability are vital for tracking model performance in production. These tools provide insights into model accuracy, response times, and resource utilization, allowing teams to detect issues in real time. By implementing observability, organizations can ensure models continue to meet performance requirements and are not impacted by data drift or changes in the environment. Effective monitoring involves setting performance thresholds, alerts for anomalies. This allows for timely intervention, preventing performance degradation from impacting users or business outcomes. Observability tools also enable root cause analysis, helping teams identify and address issues quickly. Observability is very important in regulated industries where organizations must demonstrate model reliability and accuracy. By maintaining a detailed log of model performance, companies can ensure transparency and accountability, meeting both internal and external compliance requirements. For example, consider a logistic company that uses AI to optimize delivery routes. With monitoring and observability, the company can track model performance across different locations and delivery times. If the model's accuracy declines due to changes in traffic pattern or weather, the monitoring system will alert the team to recalibrate the model. This observability ensures that the logistic company maintains efficient delivery times, reduces operational costs, and meets customer expectations. Last but not least, security, governance, and compliance also can be divided into three buckets. Access controls and role management. It ensures the data, models, and APIs are only accessible by authorized personnel. Data encryption and privacy compliance ensures data is encrypted at rest as well as in transit, along with compliance checks like GDPR, HIPAA for sensitive information. Audit logging tracks access and usage to maintain accountability, enable forensic analysis if needed. Security, governance, and compliance are critical considerations for any AI platform. Security measures protect data from unauthorized access and breaches, while governance protocols ensures that data usage aligns with ethical and organizational standards. Compliance involves adhering to industry regulations, which mandate strict data handling practices. Governance frameworks provide guidelines for model development, data usage, and deployment, ensuring that AI practices are ethical and fair. Compliance processes, on the other hand, involves auditing and documentation, which are essential for providing adherence to legal requirements. Implementing these safeguards help avoid penalties, legal issues, and reputational damage. Together, these elements establish a trustworthy AI environment and enabling organizations to scale their platform without compromising on safety, ethics, or regulatory standards. Imagine a pharmaceutical company that uses AI to analyze patient data for drug development. Security, governance, and compliance are crucial to protect sensitive data, meet regulatory standards like HIPAA. If the platform lacks these features, the company risks data breaches, legal repercussions, and damage to its reputation. By enforcing strong security and governance, the company safeguards patient privacy, ensures compliance, and fosters trust among stakeholders, which is essential in highly regulated industries. That brings me to the summary of this discussion. Basically, an AI ML platform serves as the backbone of scalable AI efforts, supporting collaboration, consistency, and cost efficiency. By building a robust architecture, automating workflow with MLOps, and ensuring data quality through scalable pipelines, organizations can leverage AI as a powerful tool for business transformations. So here are some of the key takeaways. Importance of building an architecture that supports rapid scaling. Incorporating reusable components to maximize efficiency. Implementing observability and compliance for trustworthy AI solutions. Emphasizing security, governance, and compliance is critical and should be started from day one. This helps in creating a platform that is both robust and compliant with industry standards. Finally, to conclude, scalable AI platform is not only a technical achievement, but a strategic asset. It enables organizations to remain agile, competitive, prepared for the future, aligning AI capabilities with long-term and short-term business goals. That's all. Thank you.
Wonderful. Well, this was a fantastic presentation. I know as somebody who comes from an operations and HR background, there's always a lot of questions swirling around ethics of how to utilize these models, and then the different places and different ways that we apply rules and regulations. So thank you for taking the time to talk through this. Well, I think that is the sign of a strong presentation, don't you, Sanat? Well, again, I
Thank
just
you,
want to
Emily.
thank you so much for taking the time today and to share your thought process and your knowledge. For everyone who joined us, thank you for sharing your lunch hour here. I'd like to remind you that this presentation will be available on the Improving YouTube channel. So if you know somebody who would find this information interesting, but wasn't able to join us, feel free to share this information with them. I'm sure Sanat would welcome any questions to his improving email that you might have if there was a specific area or a question you were not able to ask on the call today. Again, thank you all for joining. Just a quick reminder, we have these calls on a regular basis. This was part of our Tomorrow Technology Today series, which is coming to a close, unfortunately. But as I noted, all of the great presentations that we've had so far can be found at improving.com/thoughts. All of the presentations will be available and they are shareable. Now we're going on a bit of a break as we enter into our fall holiday season, but you can find us again next time for our regularly scheduled improving talks. That'll be on December 4th. That talk is a focus on the continuous learning culture by our own resident CEO, Curtis Height. So I hope that you're able to join us for that talk. Again, thank you, audience, for being fantastic and sharing your time. And Sanat, thank you so much. Have a
Thank you, Emily.
wonderful rest of your day.